looking at 10.1, tangents and circles. Tangents of circles, similar right triangles. We're going to look at identifying line segments and lines related to circles and use properties of a tangent circle. So a circle is a set of all points in a plane that are equidistant from a given point called the center of the circle. Again, we're going to do vocabulary words, so you should probably have these written down. The distance from the center to a point in the circle is called a radius. We've talked about that before. Two circles are congruent if they have the same radius. The diameter is the whole distance across. You want me to draw a little picture for each of these? Okay, so a circle where all sets of points are equidistant from a given point called the center. Radius goes from the center to the end. Okay. Diameter goes all the way across. These two circles are congruent if these two radiuses are congruent. Okay. A chord is a segment whose endpoints are on the circle. A diameter is also a chord, but a chord can go other places as well. A secant is a line that intersects a circle at 2 points. So a secant goes all the way through the circle. It's a line. Okay? And a tangent hits a circle only at one spot, at one point. Theorem 10.1 and 10.2. 10.1, if the line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. Theorem 10.2, if two segments from the same exterior point are tangent to a circle, then they are congruent. So if a line is tangent to a circle, it's perpendicular to its radius. So let's draw a picture of that. So if we've got a circle and we've got a line that's tangent, then it forms a 90 degrees with its radius. If two segments from the same exterior point are tangent to a circle, they're congruent. So if we've got 2 points, so my tangent line goes here, and my tangent line goes here, and they go through the same point, then these two tangents are congruent. Okay, let's name all of these special things right here. C, I want to know what F is. A point of tangency. Can somebody tell me what FE is? It is a tangent line, yep. Okay. What about HG? Radius, good. DB. Chord. And notice that it does not have the lines, so I know it's a chord. If it had the lines, it wouldn't be a chord. C is what? Center. Do you have a question? C is the center of the circle? What do you mean? Okay. BE. It can be called a diameter, but it can also be called a what? Everybody okay? Because they shouldn't be talking while I'm talking, and I'm assuming if there's talking while I'm talking, you need a question answered. Okay. DB, and it says line DB, not segment. So it's not a chord, it's a secant. Okay, line AG, tangent line. Any questions about those? You guys seem to do pretty good. All right. I'm not going to do all of these. I think I'm just going to do one of each, just so you know what they are. If we are given the diameter and the radius, if the diameter is 13, the radius would be 6.5. It's half. Yeah, it's all half. Okay, what about if my radius is 11? What's my diameter? 22. Okay, you guys get the point for those? Make sure you write 22 centimeters and 6.5 inches and all that. Okay. Now we're going to go through, we're going to identify how many common tangents these have. All right. So, and we're going to say if they're external or internal. Internal means they cross between them, external is on the outside. So we need to put our phones away. We need to write down what I'm writing down. We need to ask questions, try to understand, all that fun stuff. Okay, how many tangents do you think we have for A? 2. 1 on each side, right? 1, 2. Would those be internal or external? External. I'm going to put big E for external. How many tangents do we have in common between these two circles? This has 2, this has 0. Because it can't hit both circles. Because a tangent can't go through a circle. It can only hit a circle at one point. All right, what about C?
1.
I can see 1,
3.
2, oops. 1, 2, and 3. 3 total. External I've got 2. Internal I've got 1. Okay. What about for G? So we can have 1, 2, 3, and 4. How many external? How many internal? Okay. How many tangents can I have for E? 1. And it's external. All right, and F is just like B. All right, guys, let's turn it over. I think I have some repetitive stuff here, so bear with me. Okay. 10.3, make sure you have, do we have everything? If a line is tangent to a circle and it's perpendicular to the radius, in a plane, if a line is perpendicular to a radius, then it's tangent to a circle. If 2 segments from the same point are tangent to a circle, they're congruent. Okay. All right. So I know C to A is 8. I know C to B is 17. And I know this is 12. Right? How can I prove that this is a tangent? What about my theorems did I just learn? Yeah, what else? Look at your theorems. Tangent, then it is a tangent, right? So we're agreed that CA is my radius? Yes? Okay, so we have to make sure this forms a 90-degree angle, right? Right here. If that forms a 90-degree angle, it's a tangent. How am I going to prove, what? I heard it? Pythagorean theorem. 8 squared plus 12 squared, does that equal 17 squared? So I get 289, 64, and 144. Do they add up to each other? No. No. Not tangent. Okay, what about B? I've got 7, 25, and 24. What am I going to do again? Pythagorean theorem. 25 squared equals 24 squared plus 7 squared. Are they equal to each other? Yes. So AB is tangent. Okay, guys, we'll go over